Hello students, today we will discuss about the scalar product of two vectors or dot product of two vectors. Now, what is dot product? As you all know, the definition of dot product is well known that the dot product of two vectors are equal to the product of the magnitudes and multiplied by the cos theta. That is, a vector dot b vector is equal to magnitude of a vector magnitude of b vector and multiplied by cos theta. Let's look at this value. This whole value is a scalar value, because the magnitude of a vector is also a scalar number. The magnitude of b vector is also a scalar number, and this is the also a scalar value. So the whole value we get a scalar value. That is why it is called dot product or scalar product. Because of we get only magnitude by dividing the by producting of two vectors. That is why we called it the scalar product of vectors. Now, how we get that formula and what is the physical meaning of dot product of two vectors? Let's discuss about this. Now, I draw two vectors. Suppose this is a vector and this is b vector at some angle theta. Now, how to get this value from that vectors? Let's say the magnitude of a vector is this and the magnitude of b vector is this. Now, we are discussing the physical meaning of dot product. So, how to calculate that value from this diagram? Now, look here, the a vector is a vector which is break down into two components, the horizontal component and the vertical component. The horizontal component of this vector is this a cos theta, a vector cos theta, and the vertical component is a sin theta. Or we can say that if we put a line from here perpendicularly and projected on a vector, we get the projection of a vector on b vector. Okay, that is called the projection or component of a vector along b vector. Similarly, if you put that light in that direction, you get projection of a vector along this side, which is the vertical component of a vector. Now, the horizontal component of a vector or projection of a vector along b vector, what is the value of that projection? We write it a vector cos theta into b vector. Now look at it. What is this? A vector b vector cos theta. That is called the dot product of a vector dot b vector. So we can say that the dot product is nothing but the projection of a vector along the second vector, or the shadow of a vector along the second vector, or the component of a vector along the second vector. Now, you all understand this, but what is the daily life importance of the dot product of two vectors or daily life example of that situations. Now, let us discuss about that example. Suppose I have a box and a force acted on this box at an angle, at some angle with horizontal plane, suppose theta. That is the force. You all know force is a vector, then you treat it like a vector. Now this is the force vector. Now I want to calculate the work done by this force on that box. So the work done is equal to the force into displacement. Now look here, the force is acted on the box at some angle. So if the box displays from this direction, the contribution of the whole contribution of this force is not displaced this box in that direction. There are some component of this force which draw this box into a translational motion or linear motion because the force is acted at some angle. That's why here we get two components of this force. One component is vertical component and second component is horizontal component. So the amount of force which is acting in the direction of the displacement of the box is called the dot product of this force and this displacement vector. Understand what I say? The amount of force along the displacement, the amount of force along the displacement is called work done, and work done is a dot product of force and displacement is called work done or dot product. Now you understand the real meaning of dot product because dot product is a nothing but a projection or component along the displacement where the box is displaced. Because force is acting at some angle, that's why here we get two components of this force. This is the vertical component, which is F sine theta, and that is the horizontal component, which is F cos theta. And this is the direction of displacement. So, which component displaces that box in that direction? Of course, F cos theta. So the work done of the force by the force on that box is equal to F cos theta into x. Now, what is that? F x cos theta, and we can write it like that in dot product F vector dot x. That is why we call that work is not a vector quantity because the formula of work done is F vector dot x vector. This is dot product, and will get dot product gave us the scalar value, and the work give the scalar value. That is why it is not a vector quantity, is a scalar quantity that does not contain the direction because vector quantity have direction and magnitude both also. Now work done is only a magnitude, only the value not containing the direction. That is why work is a scalar quantity. We can write it, work is a scalar quantity. I hope you understand the physical meaning and the daily life example of the dot product of two vectors. In the next video, we will continue with the cross product of two vectors, and we will discuss about the physical meaning of the cross product of two vectors and the daily life examples. Thank you.